AlexNet and BGG16. After you have seen an AlexNet 5, what are the enhanced, more convolution neural networks, enhanced types of convolution neural networks? We are going to see them. So the first two that I have picked up for today is AlexNet and BGG16. So let us see what they are. All you have to remember in these networks is, how are they built? Okay, so you can see classical convolution neural network. If I talk, then the network models which were before the emergence of AlexNet were basically all shallow neural networks. They were not much into the depth of their neural layers. So the top 5 error rate was about 25%. With the advent of AlexNet was an 8-layer deep neural network. So it reduced the top 5 error rate to 16.4. Thus the performance was greatly reduced. After that came VGG series and Inception module, GoogleNet, etc. And they further decreased this error rate to 6.7%. And the post Inception, you have got a ResNet, which increased the number of the depth of layers to 152 for the very first time, and it had greatly reduced the error rate to about 3.5. So this was about the analysis that goes that deeper the neural network, the better it can give you as the performance. So the initiative of it was given by AlexNet. Before that, they were all shallow neural networks, less than 8-layer neural network. So AlexNet, if I talk on, AlexNet was a deep convolutional neural network architecture, and it gained significant attention and popularity because it won the ImageNet large-scale virtual recognition challenge in the year of 2012. So 2012 was the year where exactly deep learning began, and it was developed by Jeffrey Hinton and others. And the ImageNet competition, what exactly was that there were 1,000 objects categories, and you wanted to create a deep neural network which could classify images into any one of those 1,000 object categories. And AlexNet demonstrated a remarkable improvement in accuracy over any other approaches that was present in that challenge. So AlexNet was the beginning of deep neural network era. So what is now AlexNet architecture? So if I talk on architecture summary, convolutional layer, obviously the first one will be a typical convolution layer. So if I talk on AlexNet used 5 convolutional layers, and they all had smaller receptive fields. So receptive field means the size of the kernel that they were using was 3 by 3, and of course they will be followed it up with a downsampling layer or a pooling layer, and the type of pooling that it used was max pooling. Activation function, if I talk on in this architecture, almost every layer used ReLU, rectified linear unit, and it basically helped at that time to mitigate the vanishing gradient problem, and it was accelerating the convergence of the training process at that time. And the type of normalization that they were using was local response normalization, and it was applied after a combination of the first 2 convolutional layers. It normalizes the responses across the nearby channels to enhance the contrast between these activations. So you have to remember this architectural summary for the AlexNet. After this would be our normal dense layer that comes into picture. So you can see after the convolutional layers, there were 3 dense layers, each with 4096 neurons, because of course the category is too high. And as you can see, it was a 1000 object classification. The output layer or the last dense layer will be having 1000 neurons for 1000 ImageNet classes, and of course the activation will be softmax. Now if they found, because they have found somewhere the model was overfitted, so there was a dropout layer used as a regularization, and it was applied to the first 2 fully connected layers. You already know, right? Dropout is always used just a prefix to your dense layer, right? Fully connected layer. So it is applied to the first 2 fully connected layer during training, and it helps prevent overfitting by randomly setting certain number of neurons to 0 at each update. Of course, as an output activation function, as I already told, there will be a softmax function. So this was about the architecture. You want to see very clearly as a diagram, then you can see here. You have got convolution layer, two sets, followed it up with a max pooling. Okay, two sets of convolution, follow it up with max pooling, and then follow it up with, dense layers, and before that you can apply actually a dropout, and then final layer will have 1000 neurons. So this was about the architecture of AlexNet. Now moving on further with second category of the network, we have got VGG16 coming from Visual Geometric Group Network, and it is a series of convolution neural network architecture basically. You have VGG16, VGG19 also. So we are first picking up VGG16 here. It was developed by Visual Geometric Group at Oxford University. And VGG network, they are very straightforward, simple architecture. All they do is use repeated blocks of convolutional layers with smaller size of filters. Here they are chosen 3 by 3 as the size of the filter for VGG16, and definitely there will be a pooling here, max pooling, in order to downsample your spatial dimension. So you can see here VGG16 actually can accept a color picture with 3 channels of RGB. Size of the image that it could handle was 224 by 224, not bad. So what it is doing here is, in a VGG network, it actually passes through first 2 convolution pooling units, and then 3 convolution pooling. So you can see here the first patch has got 2 set of convolution layer, and then you will do a pooling, and then again 2 subsequent convolutions and then a pooling. This was one part. Another was like convolution 3 layers and then a pooling, again 3 convolution layers and then a pooling, again 3 convolution layer and a pooling. So the same convolution layer of size 3 by 3 was repeated. Here 2 sets of convolution and pooling, 2 sets of convolution and pooling, this is 2 sets, and then 3 sets of 3 convolutions and a pooling, follow it up with 3 dense layers. Okay, so this was about VGG16 architecture. I think it should be clear. I'll just remove this so that you can have a clear picture of it. So this was about same 1000 category application, and you are using a VGG16 architecture. So I have now explained you today about AlexNet and VGG16. There are further more which we are going to see in our subsequent topic.